All right, people, it's section 6.6. So, ooh, look at that picture. That is a Pokemon card of Elvis Presley. So in the past, I've made videos with Pokemon in it, or the Pokemon theme song, and I've also talked about Elvis recently because it was his birthday recently. Um, so I found this Pokemon card and it looked pretty awesome. So that's why it's there. Um, Section 6.6, the goal: I can understand and utilize properties of trapezoids and kites. So we're talking about different polygons now, different quadrilaterals that maybe are not parallelograms. Trapezoids and kites. All right, so let's start off with some vocab. What is a trapezoid? Well, if you look at the definition of a trapezoid, a trapezoid is, and actually I'm going to type this, that's why I'm moving things around here. But a trapezoid is a quadrilateral that has exactly one pair of parallel sides. All right, it's a quadrilateral that has exactly one pair of parallel sides. It cannot have two. That would be a parallelogram. So it just has exactly one pair of parallel sides. Um, a base angle of a trapezoid would be, and this is kind of, all angles could be considered base angles, but um, a base angle is if you have base angles that are the two angles that share a base. Of a trapezoid. So if you're saying two things are base angles, you have to be talking about the two that are actually sharing the base. So if we look at a trapezoid, trapezoids have two bases. I know that's kind of weird, but the top and the bottom are called the bases, and the left and right. So the ones that are parallel are called the bases. The other ones are the legs. So this would be a base, this, and this would be a base angle, or would be base angles, and these two would be base angles because they share a base. You can't mix and match. It's just the ones that share the base. All right, and then an isosceles trapezoid, kind of like an isosceles triangle, is a trapezoid with legs that are congruent. Just like the picture over to the right there. If the legs are congruent, it's an isosceles trapezoid. I know usually we picture them like that. You think of the desks in our classroom, you think of, that's what we think of when we think of trapezoids, but not all trapezoids are isosceles. Right, and one other term for this first part about trapezoids is the mid-segment of a trapezoid. The mid-segment is a segment that joins the midpoints of the legs of a trapezoid. So if you look at the picture up to the right, the isosceles trapezoid, and you picture, whoops, let's change the color of this. You picture the midpoints of the legs. So it'll probably be right here, right where the lines are for the congruent sides. Those are the midpoints of the legs, and the mid segment would be right there in the blue. Okay? A little bit different than the mid segment of a triangle, but same concept. All right, we have three theorems here about trapezoids. Well, I'll show them one at a time. The first one is the theorem 619. It says if a quadrilateral is a trapezoid, so we're assuming it's a trapezoid, or isosceles trapezoid, sorry, is an isosceles trapezoid, then each pair of base angles is congruent. So this is a pair, and this is a pair. And over to the right, they're shown with the symbols. The angle T is congruent to angle P, and angle R is congruent to angle A. So that's for isosceles trapezoids. All right? Theorem 620, if a quadrilateral is an isosceles trapezoid again, then its diagonals are congruent. Interesting. So if we do the diagonals, we can say that this diagonal on AC is congruent to BD. This is if it's an isosceles trapezoid. And the third one is dealing with mid segments. It says if a quadrilateral is a trapezoid, doesn't matter what type of trapezoid, then two things. The mid segment is parallel. So if we have a trapezoid, the mid segment is parallel to the bases. And the length of the mid segments, this one's interesting. The length of the mid segments is half the sum, not half of one of them, half the sum of the lengths of the bases. So if you were to look at this, we have the if part over in the middle here. The len, we have that MN and TP are parallel, and MN and RA are parallel as well. And the second part there tells us the mid segment MN is half the sum of the other two the two bases. All right, we're going to use that a little bit now. So first of all, let's do number one. Number one says, find the measures of the numbered angles in each isosceles trapezoid. So if we're talking about isosceles trapezoid, we know that the base angles are congruent. So measure of angle 1 is also 58. Now we also know that 2 is congruent to 3, and we know that all 4 of them have to add up to 360. So if these two combined are going to be 58 plus 58 is going to be 116. Take away 116 from 360. 360 minus that. We have borrow there. We have 4, 4, 2. 244 is left for the other ones. And divide that up by 2 because the measure of angle 2 and 3 are congruent. So measure of angle 2, measure of angle 3, half of that would be 122. All right, similar thing for number 2 there. Let's go to the second part. Find the values of the variables in each isosceles trapezoid. All right, we know that the base angles are congruent again. We're going to do number 3. 117 is congruent to 3n. Set them equal to each other. And solve for n. Whoops. But again, we're trying to find the values of the variables, okay? So it doesn't really matter about the angles right now. We just want the variables. We know they're both going to be equal to 117, though. Divided by 3, n equals... What's 117 divided by 3? I forget. That goes in 3 times. 9, 2, 7. That goes in 9 times 27. Nothing left. So 39 would be n. All right, and last set of examples. Just do one of these. Let's do, well, it says algebra. Find the lengths of the segments with variable expressions. Let's do number 6. This comes straight from that second theorem, or sorry, that third theorem. Since we're dealing with lengths of mid-segments, let's use the second part of this third theorem, where the mid-segment is half the sum of the other two, the two bases. So this mid-segment, 2x plus 1, has to be equal to half of 4x minus 2 plus x. Now again, you could make it a little bit different. You could say that 4x minus 2 plus x equals 2 times the 2x plus 1. There are just two different ways to do it. So this one here would actually be, if we get rid of that, this would be 5x total minus 2. And then I'll distribute. Or you can multiply by 2 on both sides, whatever. That would be 1/2 of 5x. Oh, 2.5x? What is that? Oops. I'm going to do it differently. Then I'm going to have to double everything anyway. Well, yeah. How about we do it the other way? Instead of setting it up like that, let's do 2 of the 2x plus 1 equals 1/2, or sorry, equals 4x, I'm all over the place here, minus 2 plus x. Alright, so when you distribute on the left side, we have, so again, this is the way I'm doing it instead, 4x plus 2 equals, those two would be 5x minus 2. If you subtract 4x from both sides, and you add 2 to both sides, you are left with 4 equals x. So there you go. X equals 4. Alright, if I plug those back in, let's just think. This would be 4 up here. This would be 4 times 4 is 16 minus 2 would be 14. And 4 times 2 is 8, that would be 9. Alright, so that one is half of the sum of the other two. That works out. And it looks right when you look at it. Alright, so second part of this lesson is dealing with another shape, and it was that other shape called a kite. A kite is a quadrilateral. I know a kite is a thing you fly in the air, but it's also a shape. It's a quadrilateral with 2 pairs of consecutive sides congruent and no opposite sides congruent. So opposite sides cannot be congruent in a kite. Those are the 2 parts of it. And we have one theorem about kites. That's theorem 622. It says if a quadrilateral is a kite, then its diagonals are perpendicular. It's the only thing we have right now for a theorem about kites. So if it's a kite, diagonals are perpendicular, kind of like a rhombus. But again, opposite sides cannot be congruent in a kite. So just a couple examples about kites. The first one I'd like to do is number 1 here. Find the measure of the number of angles in each kite. We know that this is a right angle since these are perpendicular. If we know that that small angle is 18, the measure of angle 18, or sorry, the measure of angle 1 plus 18 is going to have to equal 90. So if you subtract 18 from both sides, the measure of angle 1 equals 72. Now, you can look at this a different way too to figure out the measure of angle 2. Picture this whole triangle right here with its congruent sides, meaning it's an isosceles triangle, so the measure of angle 2 has to also be the same as the measure of angle 1. So the measure of angle 2 is also equal to 72 degrees. Let's just check where we're at for time here. Alright, we'll be finishing up here quick. Got 1 or 2 problems left. Let's go down to number... You know what? Let's do number... Let's do number 2, how about? Number 2 is slightly different. We need to find the measure of angle 1 and 2 again. So what do we know about opposite angles of a kite? So let's look back. 2 pairs of consecutive sides congruent and no opposite sides congruent. We know that the diagonals are perpendicular. Do we know anything else about kites? Let's think here. It's a quadrilateral. 4 sides. Well, we can say that opposite sides are going to be congruent based off of a couple different things. Or sorry, opposite angles are going to be congruent. No, opposite angles are not going to be congruent. We cannot say that. So, now in a roundabout way, we can say that one set of angles is congruent. Because if you draw those perpendicular lines, and we have 2, we don't even need to draw the other one. We have 2 isosceles triangles. If this is congruent to this, and this is congruent to this, then those 2 opposite angles are congruent. The other opposite angles we do not know are congruent. But we do know that the those 2 angles would be congruent. So if I erase this, I can say that the measure of angle 1 is going to be equal to 110. And that leaves for the measure of angle 2, that's 110 plus 110 plus 98, be 220 plus 98 would be 318, and to get to 360, that leaves the measure of angle 2 to be equal to 42 degrees. Alright. Let's go on from there. We'll do one more. This last one is number 5. Find the values of the variables in each kite. we have that this top one is 3x plus 6. We have this one right here is 4x. And we have that 2x plus 6 is to that bottom one. Now we know this is also a right angle. The diagonals bisect each other. So that the 4x, that leaves 90 degrees to be equal to the 4x and the 2x plus 6. So that would be 6x plus 6. Subtract 6 from both sides. If 6x equals 84, and then we just have to divide both sides by 6 to figure out what x is equal to. What's 84 divided by 6? 1. That is 14, so that would be 24. Alright. X equals 14. And that's all it's asking you to do, is find the values of the variables. So we're done with that one. We're going to skip these bottom 4 for right now, and you can just take a look at the closing questions, and by next time, please have the closing questions answered. Alright, that's it. We'll see ya.